Hello, everyone, and welcome to the 12th SETS Online webinar. We are thrilled to have you join us today, and we appreciate you taking the time to join us from around the world. Today, we have four awesome speakers who will be sharing their insights on the topic morphodynamic approaches to fluvial sedimentary processes. I'd like to remind everyone that this webinar will be recorded and posted on the SETS Online YouTube channel. So be sure to check it out along with previous videos and resources that have been posted on the SETS Online YouTube channel and the SETS Online website. So as I mentioned earlier, we have four speakers today. We have Laura, Natalia, Ismaila, and Sunny, and they'll be speaking to the topic. And for each session, each speaker would have 10 minutes for their presentation, followed by a 5 minutes questions and answer session. So during the presentations, the chat will be closed and it will be open towards the end of the presentation to allow you type in your questions. We would request that you add your names and where you are asking your questions from. If you also have follow-up questions during the course of the presentation, please feel free to type them in the chat and indicate which speaker the question is directed to. I will read it out and allow the speaker later to answer and respond to your questions. So without further ado, I would invite our first speaker, Laura. Laura, if you could share your screen for us.
I'm sharing.
All right.
My screen.
Yes. All right, perfect. Thank you.
Thank you. Hi, everybody. I am Laura. I am first-year PhD student at the University of Pavia. And today I would like to share my research on the contrasting post-glacial morphodynamic evolution of alpine and Apennine river systems, implications for physical stratigraphic models. So let's start with a simple question. What is sequence stratigraphy? The sequence stratigraphy has its roots in 1970s within coastal and marine environments in the fields of petroleum explorations and seismic stratigraphy. The main goal of the sequence stratigraphy is to understand how the sedimentary systems can respond to the base level changes and to understand the interplay between the space accumulation and sediment supply in the sedimentation patterns that are present in the stratigraphic successions. Generally, the basin sedimentation is controlled by allogenic and autogenic processes, but the interplay of all allogenic processes, so tectonics, eostasy, and climate, is important for the shoreline shifts that are important for recognize the packages of strata known as system tract. But how does it work for the continental systems? So, for example, in the fluvial record. So the river systems are challenging because they respond to multiple drivers with variables responsive depending on the relative roles of upstream and downstream controls. So clearly, if we are to the seaward, we have a control by the sea level changes. But if you are at the landward, you have control by upstream factors like climate and tectonic, so subsident and uplift processes. But we have also some complexes in the fluid architectures because we have the influence of the autogenic processes like avulsions that complicate the stratigraphic units. So basically, the traditional sequence stratigraphy models are simplistic because they represent situations in which evolution is led by variations in the base level instead of changes in the equilibrium profile of streams caused by upstream factors. So for my research, the Po Basin is an ideal laboratory because it's a large alluvial basin in the northern Italy influenced by Alps and the Apennines. It's sensitive to climate changes, tectonic variations, and eustatic fluctuations. There are a lot of papers in the bibliography on the coast and marine areas because the late quaternary sedimentation occurred under strong eustatic control, and the last glacial interglacial cycle is characterized by pre-last glacial maximum sea level fall, which is the end of forced regression during the low stand conditions, followed by transgressive and high stand conditions, which are still ongoing. In particular, my study area is in the center of the Po plain, so we are far to the marine conditions. The study area is along a transect from Pavia to Piacenza cities. We have the influences by the Apennine and the Alps basins. So as you can see in the northern part, we have the Apennine, the Alpine tributaries with the higher altitudes, magmatic, metamorphic, and sedimentary rocks, generally with coarser grain sizes. But in the southern part, we have the northern Apennines with the lower reliefs, sedimentary rocks with the region's contribution and variable sediment supply. So as you can understand, my research is based on stratigraphy and geomorphology. So here I want to show you my research questions and my objectives. So the first one is how differently do axial and transverse fluvial systems, so the Po River and its tributaries, can respond differently to climatic and tectonic forcing in the late quaternary. And the second question is how are differences in the morphodynamic response of fluvial patterns preserved in the sequence stratigraphy of basin fill? And I have also a more applied objective. Is it possible to develop a conceptual sequence stratigraphy model that can be applied for basin-wide correlations of stratigraphic packages? And for respond to these questions, I use a multidisciplinary methodology. In fact, my research is based on the first part on the geomorphological and pedological analysis with the identification of geomorphological features, characterization of soils and their horizons by sediment textures, structures, and colors, with the integration of multi-source data, for example, historical maps or archaeological findings. This is useful as an actualistic analog to understand the subsurface sedimentary record. In fact, the second part of my research is based on stratigraphy and paleosols, with some sedimentological studies of core drilling surveys associated with public domain subsurface legacy data, then paleosol macroscopic and microscopic analysis, provenance analysis, and of course the integration of dating analysis, for example, radiocarbon and pollen spectra. So here I want to show you a first overview of my initial findings. Here you can see a geological section of the northern part of my study area. And as you can see, we have two parts of this section of low stand conditions, two parts of high stand conditions. Here is the Po River, and probably other two parts of transgressive conditions. So this system tract, so these conditions are based on some chronostratigraphic constraints like bibliography and some historical maps. On the other hand, we have also a new section of the southern part where we have two parts of high stand conditions, and these data are based on new archaeological data and bibliography and historical maps. And we have just high stand condition in the Po River and high stand condition in the Apennine area. So these results shed light on the contrasting morphodynamics of the Po plain. In fact, we have a northern part with deeply incised valleys with active fluvial erosion and controlled by climate forcing with a strong influence of the last glacial maximum. On the other hand, we have the southern part, so the Apennine tributaries with hanging valleys relative to the Po plain. In fact, if you look at this DTM model, you can see the Chiavenna and Arda rivers with an hanging behavior. And we have the control of tectonic with subsident process and the climate, but without a strong influence of the last glacial maximum. So in conclusion, in this study area, we have some systems that follow out-of-phase cycles of aggradation and incisions driven by climate control over flow rates and solid load, with alpine tributaries evolving from proglacial outwash conditions to the current configuration, while the southern margin of the Po plain is characterized by elevated alluvial fans and channel deposits where the topography controls sediment distribution and connectivity of shallow aquifers. So here you can see that there is another implication of my research. In fact, this can apply for the characterization of the shallow aquifers of the entire Po plain. So I want to leave here two take-home messages. The first one is, of course, that post-glacial fluvial evolution in the Po plain shows contrasting dynamics, aggradation in the southern catchments and incision in the northern tributaries, and of course, along the Po River. But we have also some results that can offer a framework from interpreting the regional stratigraphic architectures and for comparing the last 15,000 years evolution of sequence stratigraphy models. So that's my research. Thank you for your attention. If someone have some question, I will be here.
Thank you very much, Laura. I'll like to say the chat is now open. If you have any questions, you can type it in the chat and send it to everyone just so that I can read it out to our presenter to answer your questions. But while we wait, Laura, I just had a question that in distinguishing between the alpine and the Apennine sediment inputs, was there like the sediment supply, was there like any diagnostic indicator for some of these sediments you looked at?
Yeah, so you mean there are some no, so I can't understand your question, sorry.
So for the sediments, distinguishing between the sediment supply from the Apennine and the alpine, what were some of the diagnostic indicators for those two sediment supplies here?
Oh, yes, of course. In the Alpine basin, we have, as I can see, some metamorphic and magmatic rocks, but also some sedimentary rocks. But we have also some minerals as diagnostic proof, like, for example, quartz and the others. In the Apennine, we have just terrigenous contribution. So, for example, limestone or Mars, for example.
Okay. So did you for that, did you see any sort of alterations, particularly with the limestones?
Yeah.
Any diagenetic alterations that were recorded in some of these sediments or limestones? Yeah.
We are looking for some diagnostics.
Yeah.
Yeah. So
Okay.
I will. I'm working on.
Okay. All right. That's great. We have a question from Eric in Houston, Texas. Are
Uh,
there any differences in the rate of sediment supply or structural history between the two areas?
Very sorry. Okay. We are working on the different rate of sediment supply, but it's evident that we have some diagnostic proof of the erosion and the sediment supply in the northern part, but we don't have any data in the Apennine parts, so we are working on it. And yes, of course, we have also some structural history differences. For example, we have important truss on the front of the Apennine, so it's important for the subsidence process.
Okay.
I can't listen. Okay.
Eric, I hope that answered your question. If not, you can give a follow-up later. So we have a question from Omar Karkuk from Iraq. His question is, for provenance studies, are you using geochemical evidence or depending on petrographic study? Can you please provide some details on the methodology you
On
used?
our, okay, thank you. On our idea, we will use some petrographic studies with, for example, thin sections, but maybe we can use also some geochemical evidence, but maybe we will think about it in the future. For now, we want to study the petrographic data.
Okay, all right. So those are the questions we have. If we get any, I would redirect it back to you. But thank you very much. Okay, we have a follow-up from Eric. He says, just wondering how the differences between the two areas influence the fluvial morphology and how they respond to sea level variations.
It's the differences between the two area influences is of course the earth of my research, and for the sea level variations, the study area is part of the marine conditions, so we don't have a strong influence of the sea and the eustatic variations. So we have just climate and tectonic processing with a strong influence on the study area.
Okay. All right. Well, thank you very much, Laura. And we would now bring in our second speaker, Natalia. If you could share your screen. And if you have any follow-up questions, you can also type it in the chat and I'll read it to Laura later for clarifications.
Hi, everyone. Can you hear me properly?
Yes, we can hear you. Thank you.
Okay. Can you see my presentation also?
Yeah, we have it now. Yeah, thanks.
Okay. So, hello, everyone. My name is Natalia. I'm doing my PhD at the University, Autonomous University of Barcelona. And although my PhD topic is in a different line of research, we are developing this work on fluvial reservoirs along with my colleagues Ricardo and Luis Miguel Yeste. And the objective of this work is of a more applied nature, specifically focusing on how the sedimentary morphodynamics of modern fluvial systems can be applied to reservoir modeling in the subsurface, whether for production or subsurface storage. And I'd like then to start with a short introduction about fluvial reservoirs, which exhibit marked heterogeneity due to the occurrence of permeability barriers and to fluid flow at multiple scales. And as a result of these fluvial reservoirs, fluvial reservoirs present a high degree of compartmentalization. If we consider the geobody scale, the 3D arrangement of geobodies like channels, point bars, overbank deposits, etc., exert a first-order control in the flow behavior. So connectivity of reservoir geobodies is associated to the vertical and lateral stacking patterns of the fluvial system. And both are at the same time controlled by channel migration and meander cutoff processes. Whereas the scale, preservation, and expression are modulated by allogenic controls as tectonics, climate, and eustasy. All of this introduce complexity when it comes to fluvial reservoir modeling, and for this reason, it's particularly challenging. The goal in reservoir modeling is to predict the fluid behavior inside reservoir, and for this reason, robust models are required. So, geostatistical techniques are designed to tackle this challenge, and there are several different methods or algorithms, but in this study, we have been working with multiple point statistics. These methods quantifies, sorry. Oops. Oops, sorry, got lost. This method quantifies spatial relationships by extracting neighborhood patterns from training images. These training images are pixel-based representation of the patterns present in fluvial reservoirs in this case, and in its sedimentary structure. One of the main issues of using this method is the availability of the lack of representative training images that capture the three-dimensional relationships of geobodies. So for this reason, the aim of this study is to develop a workflow to construct a three-dimensional and geologically realistic training image from historical satellite images, and to perform multiple point geostatistic simulations to assess how effectively patterns and distribution of geobodies are reproduced. First, we must look for a modern analog that meets some criteria. To capture the full spectrum of fluvial geomorphic features, the chosen modern analog must undergo high rates of morphological changes driven by rapid succession of erosion and deposition events, so that the dynamic patterns of the river are captured. Respecting the satellite images quality, it is important to find an historical sequence of images with long-term coverage availability and free of atmospheric interference and overlapping. So in our case, after considering this criteria, we selected a section of the Mamure River in the Bolivian Amazon basin, for which 37 years of images were available. Once the images were acquired from the satellite imagery source, in our case, we used Google Earth, we systematically digitized all the images from the sequence, identifying the different subenvironments of sedimentations. This way, we individualized geobodies that will build the sedimentary architecture of the fluvial system. After this, by stacking the digitized images, we build the layers of the 3D training image. This three-dimensional training image will it has to be modeled like any other model in a modeling software. And apart from stacking all of the digitized imagery vertically, in order to achieve geological realism, deposition and erosion must also be taken into account in the vertical axis. So we modeled these processes by assigning different sedimentation and erosion rates to each geobody. So this is the resulting three-dimensional training image. And you can also see the animation that shows the temporal evolution of the fluvial system, capturing meander translation and rotation, associated bar accretion and bank erosion, neck cutoffs to channel formation, and channel avulsion. As we can see in these cross sections of the training image preserves the three-dimensional geometries and the stratigraphic coherence. You can see the channels, point bars, and oxbows that exhibit realistic lateral migration and vertical and lateral stacking. Successive channel abandonment and reincision generate fining upward amalgamated channel bar complexes. So thereby, the depositional architecture is reproduced. The fining upward trend is represented here by the progressive abandonment of channels, transitioning from the main channel deposits in yellow to secondary channels in light blue, and eventually to the establishment of oxbow lakes represented in green. For the geostatistical simulation, using multi-point statistics, two scenarios were generated. In a scenario 1 of simulation, the input data consists of 3 vertical logs that represent the vertical stratigraphy of 3 locations, indicated by the blue dots that you can see in the figure. These logs are extracted directly from the training image and used as a conditioning data for the simulations. And the second scenario combines the same conditioning data with a probability model that defines the likely channel position. This is done because in real reservoir studies, such information like the trace of the channel can be inferred from high-resolution seismic data, for example. And here, the results of the MPS simulations. The models on the left are the results of the simulations after 3 realizations for each scenario. And to test how well the simulation reproduce the reservoir geobody of interest, which are point bars, we have calculated the probability of occurrence of point bars geobodies, and it corresponds to the model on the right. In a scenario 1, the probability of point bars occurrence is concentrated around the 3 vertical logs that I mentioned before, indicating a high likelihood of point bar presence of this area and a high degree of spatial uncertainty in unsampled regions. In contrast, in a scenario 2, it shows a more continuous distribution of high point bar occurrence clustered around the same locations, thereby reducing uncertainty and suggesting limited variability among 100 realizations. So the conclusions so far of this work is that the generated three-dimensional training image successfully captured the structure of the fluvial system, and that the MPS simulations consistently reproduced the proportional spatial distribution of the digitized and identified geobodies in the historical images, satellite images, in alignment with the sedimentary architecture characteristic of a high sinuosity fluvial reservoir. And finally, the point bar positions are eventually reproduced with a high fidelity when the channel position is known, revealing the strong impact of input data on MPS simulations performance. So here are some references that I can send to you if anybody needs them or would like to have them. Thank you so much for your attention. I think I extended a little bit further. And if you have any question, I'll be happy to answer.
Thank you very much, Natalia. Right on time, actually. So the chat is open if anyone has any questions. In the meantime, Natalia, I do have one question, and it is your workflow, the workflow you went through, is it directly applicable to different basins using the fasces you provided, or maybe altering the categories or fasces for the training image?
Yeah. You mean for the workflow used for building the training image, or for
Yes,
the MPS
exactly.
simulation? Yeah.
Yes.
Is flexible. You can change any parameter, you can change erosion rates. It's completely adaptable to any other sedimentary system type or to any other basin.
Okay. All right. Thank you. We do have some questions. So this is from Shraddha, India. Shraddha from India. She says, "Hi, great talk. I was just wondering what could be the minimum spatial resolution of the satellite image to get a high fidelity simulation?"
Minimum spatial resolution. I would say that it depends, spatial resolution of the satellite image. Yeah, I would say that it depends on the scale you want to model, or the scale you want to capture. If, for example, for our study, we wanted to capture point bars, channel. So the resolution that was available in Google Earth was completely fine. But if you want to go on a if you want to zoom in a sedimentary system and capture like high frequency variability, or maybe, I don't know, it also depends on the let's say the size of these geobodies. For example, in our case, we were working with a very big river, so Google Earth resolution was fine. But if you want to capture as smaller sedimentary environments, maybe you would need to use higher resolution or any other imagery source, I would say.
Okay. I hope that answers the question, Shraddha. Georgina says, "Thank you." We have a question. It says, "Very good presentation. I want to know, how can you get a dynamic model of the historical fluvial process?"
Yeah, we don't model the fluvial processes directly, but what we do is to do like a facies map, or a digitized map of the sub-environments, and we stack all of them one on top of them, and then we assigned erosion and sedimentation rates to each depositional sub-environment. I don't know if that answers your question. So that way, when we run this workflow in Petrel, we have used Petrel, then as a result of this, we get the three-dimensional training image, which is actually a model of the fluvial system.
All right. The next question is, what's the smallest scale you would be confident or recommend modeling?
Okay. I don't know exactly what you mean by the scale of the modeling, but it depends on the reservoir you want to model. Depends on the scale you want to use, and also the scale that you want to capture. Because as we all know, you have mesoscale, and so we are not modeling porosity, permeability. We are just modeling geobodies at this phase of the work. So I just need imagery, satellite images that can provide geobodies information and variability, and that is observable.
Okay. We do have some more questions. I'm just gonna read. I'm just gonna go ahead and read all of them then. So, so far your simulations focus on fluvial architecture and the presence or absence of sand bodies, and not on grain size variations within sand bodies. Do you plan to include this level of detail in the future?
Yeah, that might be a further step of the work, but before doing that, we need to make sure that this workflow is worthy. That's why we are working on a, let's say, easier scale to work with, which are geobodies. And I mean, we already had some good results on the point bar distribution simulations, but maybe in the future we could add some phases or grain information to these geobodies.
All right. Last but one. So sorry if I missed it. Can you please explain how you transform the information from a recent analog, say the Bolivian river in our case, to your steady model? How did you digitize the patterns from recent example? This is from Omar, Iraq.
Okay. What we did is, you can digitize in whatever software you can use. Illustrator, you can use QGIS, ArcGIS, whatever, anything that, even PowerPoint. It's just about making polygons. So, yeah.
Okay. There was a question earlier I missed. He says, what software did you use to carry out your modeling, and how did you QC the model? And just to also add, could you also add how you validated your model? Also a question from Sunny, just to add up.
Okay, I can read the question. It's on the chat.
Yeah, the question was, what software did you use to carry out the modeling, and how to QC the model? It's from Sejen.
Is it? Oof, I don't understand the question. Sorry, I think I don't get it.
I guess he's just trying to find out what software you used in your modeling, like to model your final figures or your final results. But in any case, I would ask that you, Sujin, could you come back on it later, and then she'll
Okay.
respond to it. And then Sunny wanted to know how you validated your model.
Yeah. Yeah. We validated. We did an uncertainty analysis that I couldn't include here because I was gonna take a long time to explain. So
Okay.
we performed an uncertainty analysis to see how the MPS simulations predict the value of each cell of the model and compare it to the training image. So the model has millions and millions, I can't remember right now, but millions of cells. Each one has a value. With values, I mean main channel, Oxbow Lake, blah, blah, blah. And so we did an uncertainty analysis by comparing all the cells, if the cells in the models were the same, in the same position that in the training image. And so let's say that the probability, it was good because of the probability, the occurrence, the point bar occurrence probability showed good results because the simulations proved to be good. in the uncertainty analysis. That's why the point bands occur in the places or in the cells we expect them to be, let's say.
Okay. We will hold on with any further questions and move on to the next presenter and then come back to it when we have some time. Thank you very much, Natalia. Our next presenter, Ismaila, could you please share your screen? And whilst he proceeds to do that, we would suggest that you add your name and where you are asking your question from. Thank you, whenever you submit your questions. Thank you. Ismaila?
Okay.
Natalia, could you stop sharing your screen?
Can you see my screen?
No.
Okay, give me a minute.
All right.
What about now?
Yeah, we can see it. Could you put it in presentation mode?
Yeah, of course.
All right,
Okay,
take it away. Thank you.
you're welcome. Hello everyone, and thank you for joining this session. Today I will be presenting on my previous study when I was studying my master degree in my homeland, Cameroon. The topic of this presentation will be the morphodynamic and structural control on fluvial sedimentation in Meritrud, Adamawa, Cameroon. Even though the Mberi Rift show distinct landform and drainage pattern controlled by major tectonic structure, such as the Central Cameroon Shear Zone, the volcanic line of Cameroon, and the Benue Triple Junction, the area remains poorly studied in terms of geology, geomorphology, stratigraphy, and tectonics. So this work aims to reconstruct the sedimentary and tectonic dynamic of the Mbere Basin using morphodynamic and structural analysis. In terms of geology, the area of study belongs to the Central Cameroon domain, characterized by Cenozoic volcanism, mainly basalt, arcosic sandstone, and conglomerate, and also by a basement made of Pan-African granitic gneissic, shown here in red in the map, on the geological map. The hydrographical network reveals a dendritic network with parallel confluences, most river flow oriented west-southwest, east-northeast, northwest-southeast, northeast-southwest, and north-south. The study area show a bimodal relief. We have the first unit, which is a plateau ranging from 1060 to 1300 meter in elevation, which with moderate slope between 0 to 20 degree. It is mainly composed of basalt, as you can see here in blue in the geological map, and it corresponds to the upper surfaces in blue here in this digital elevation model. The second unit consists of shallow valley between 850 and 1060 meter with gentle slope under 5 degree. made mostly of sandstone and basalt, including both intermediate and lower surface, represented in the dam in yellow and green. We can observe the slope map, which show high slope area represented in red between two units. And we also, from the digital elevation model, topographic profile oriented north-northwest, south-southeast, river normal boundary fault that delimit the Mbere Rift. The geomorphic response were analyzed through longitudinal profile, which can be grouped into treatment type, equilibrium profile, such as that of the Mayo Dadi, the concave profile exemplified by Mayo Baji 2, and the convexo-concave profile, like the one of Indigo River. These analyses based on three groups of geomorphic indices, like the uplift indicator, which include profile relative uplift and streamline gradient. Relative uplift with a value of 1.66 belonging to class 1 indicate a significant mass transfer from deep to the surface, which may be related to a volcanic isostasis process. The streamline index value ranging from 53 to 184 fall into class 3, suggests a moderate tectonic activity and stream incision controlled by lithostructural factors. We also have tilting quantification indices such as the asymmetry factor, the topographic symmetry factor, and the hypsometry integral, classified as type 2, which show that the basin is mature, showing the tilting and strong erosional activity across the Mbere Trough. In addition to the geomorphic parameters, several planation surface and slope break were also observed. The planation surface appear as elevated relief on the horizon, as you can see on those pictures here. They show a variable height reaching up to 75 meters. The figure on the right illustrates one of these features. Among the 12 Nippon represented in red on the geological map here, 7 of them were convexo-concave, clearly reflect the tectonic influence of the zone. According to some authors, the upper, intermediate, and lower surfaces correspond to H-plane and peneplane, and the volcanic rock observed in Adamawa have an age between 11 to 7 million years. The age can therefore be associated with the planation surface developed on volcanic formation. Several coincidences between the orientation of river courses and those of the structural feature, such as fracture dike and extensional joint, suggest a clear structural control on the drainage network. The sedimentary facies consist mainly on sandstone and various grain size. The sedimentary structure observed in this area were mainly cross-bedding, cross stratification, horizontal bedding, as well as giant kettles. in this sandstone bedrock, indicating intense erosional processes and turbulent flow with which suggests high energy fluvial condition during the incision. The stratigraphic data were summarized in lithostratigraphic column. The one represented here show a positive grain size grading extending over 9.93 meters, suggesting a sediment depositional during the base level fall from offshore to onshore, associated with a decrease in transport energy during sediment accumulation. The main facies, which were conglomerate, microconglomeratic sandstone, and coarse grained sandstone, were sometimes interrupted by siltstone and clay. But the chemical analysis reveal a composition of 90% of silica, which show the detrital nature of those formations. The all analyzed strata show consistent geochemical ratio, confirming active sedimentary processes such as the ratio uranium-thorium, yttrium-holmium, which suggests a fluvial environment in an oxic environment. The rare earth spectrum display a positive uranium anomaly and mark enriched in light rare earth element and medium rare earth element relative to high rare earth element, supporting the continental depositional environment. The cesium and lanthanum anomalies observed on the rare earth element diagram together with the europium versus proncium plot highlight a positive uranium and cesium anomaly across all strata. Altogether, these geochemical analyses demonstrate that the sediment were deposited in oxic continental fluvial environment with no marine influences. This structural interpretation based on fracture Rose diagram and pole plot reveal the dominant tectonic trend north-south, east-west, and northwest-southwest, consistent with those reported by by certain authors. The strand field analysis indicate also sigma 1 oriented northwest, southeast, and sigma 3 oriented northeast, southeast, confirming that the basement structure in the study area share the same tectonic framework in the Adamawa domain. In terms of sedimentology, stratigraphical study have been done. There also up to 3 measurements have been done, and the main structure, the main orientation were northwest, southeast, and non-northwest, southeast. Those orientation also match with certain authors and with certain previous paper, such as the orientation, the one with the orientation of the Cameroon volcanic line, which is north 30 degree, or the Central Cameroon shear zone by certain authors. In conclusion, we can say stress ratio and indices made it possible to reconstruct three distinct tectonic regimes, which can be an extensional regime oriented north-northeast, south-southeast, and northwest-southeast during basin formation. A strike-slip regime in two successive phases, which are northwest-southeast directed phase followed by a north-south directed phase, and a transitive regime marked by development of northwest-southeast trading fracture and north-northwest south-southeast oriented normal fall. These results obtained combined with previous work allow us to establish the relative chronology of the tectonic events that affect the basin. This is the relative chronology where we have where you can see directly here, and so we have reconstructed the main event that affect the Beirut basin. Thank you for your attention, and yeah, that's all.
All right. Thank you very much, Ismaila. Because of time, we would just move on to our last presenter. If you have any questions, just type it and we'll read everything at the end for both presenters to respond to your questions. Thank you very much, Ismaila.
Thank you.
Sunny, could you please go ahead and share your screen?
Okay. So I think like Ismail, I have to stop it. Okay.
Yeah. And whilst he's sharing his screen, if you have questions for Ismaila, please type it in the chat and I can read it to him. And he and Sunny could take turns to answer your questions finally. Thank you.
So my screen is visible?
Yes, presentation mode.
Okay, can I start?
Could you put it in presentation mode?
Yeah, it is in presentation mode.
Okay, all right, great, thank you.
Okay, so let's start.
Yeah, go ahead.
Okay, thank you. So hello everyone. So my name is Sunny Kumar Jha and I am from IIT Gandhinagar. I'm doing a PhD here. And the topic which I'm going to discuss is about the tracing the geomorphic variability in the regulated Narmada River, a major tropical river system in India. So before I'm going to start my presentation, so I'll just tell you about this river. So you can see here the statue. So the world tallest statue is also you will find here in along this river. So yeah, so I start with the content. So these are the contents which I'm going to discuss in my further slides. So first I will start from the introduction. So before I'm going to start with the main topics, I'll just give you the number. So how the important is the tropical region is. So based on this scale, like in the global scale as well as in the regional scale, you'll see the area covered by the tropical region and the populations. So these numbers show a significant, like these numbers show a significant how this the region is. Other than this, we all know that the river is a dynamic geomorphic agent and which sustain the ecosystem and the society. And if I talk about the tropical rivers, so tropical rivers, like if the tropical rivers is more variable in the terms of rainfall. So if there is any change in the rainfall shift, so it's ultimately causes the floods or the drought, and it also risks to the mankind as well, ecosystem and the infrastructure. So for that, there is management required, and that management should be in the catchment specifics, which give us insights into the diversity, the connectivity, and the evolutions of the river. So for that, I have used the river style classification, which is globally applied process-based river classifications and management tool, which is helps to understand the river at very rich scale, at very, you can say, the centimeter scale as well. So now the question is, what is the motivation why I have chosen this river? So if I talk about the global river all around the globe, so based on all the rivers, the peninsular Indian river, that is Narmada and Godavari, shows a great variability, as you can see in the graph here. As you can see the graph here, where I have put the red circle with this triangulated plot. So these are the two rivers. One of them is Narmada, which shows a great variability. Apart from this, the rivers have a great high erosional rate, which is around a 500 to 800 ton kilometer square per year. Erosional activities is going on. If you compare with the other rivers all around the globe with the same climatic condition and the geological setting, it is exceeds far beyond of that. Apart from this, as I have already given the topic, is that is regulated river. So there is like large number of dams. I think the major dams in India is constructed in this river, which makes this river more dynamic in terms of the geomorphic processes. And because of that, the 75% of the sediment load is trapped in this in this river, which affects the geomorphic processes. And due to this, like I have like proposed here the four objectives, and these, out of these four objective, I'm going to discuss only the two because of the time constraint. I'm not going to give tell you about the third and the four objectives. So I will first discuss about the river styles along the Narmada River, and what are the identity, like how these river styles are different from each other. It means like what are the factors which controlling the diversity and pattern of the river style. So this is my study area. So Narmada is one of the largest river in India. It is the fifth largest river in India, and it's around 1,300 kilometer. And these are the field survey area where I have visited to validate my all the data and the geomorphic parameters. As you can see here with the square bracket. And these are some of the gauging stations from where I have taken the hydrological data. Apart from this, if I talk about the study area, so this basin is mostly covered by the Deccan Trap, that is lithologically, it is basaltic in nature. And apart from this, the rainfall pattern, if you go from the upstream to downstream, there is a drastic change in the rainfall pattern, but the average rainfall in this region is around 1,178 mm, which is quite significant for the tropical river. And if I talk about the methodology, so these are my three methodology. First one is like the geomorphic characterization, which for this I have using this tool. These are the tools, the ArcGIS and Google Earth Pros and Google Earth Engine. And for hydrological analysis, like for the flood frequency analysis, I have taken the historical data from the government agency like CWC, and this data is from 1980 to 2020, which is used for quantify the stream power and any unit stream power. And the last, that is the more important part of my research, is the field survey, which is the more important for the validation of these all the methods which I am going to done. So just I'll tell you the more details about my methodology. So first I did the classification of this this large basin into three units. That is the hilly terrain, and then the yellow color shows the Rift Valley, and the last one, which is near the Arabian Sea, which shows the alluvial plain. So this unit helps us to identify the nature of the river. Why? So if I take the basin, so if you go from the upstream to downstream, the river changes from its river changes its landscape. So you will see there is hill surrounded both of the side of the river. You will find the hill, but as you go downstream, there you will find like one side you will get the hill, or other side you will not get. So based on that, I have divided the river into confined, partly confined, and laterally confined. And more important, there should be a floodplain which shows that the river is confined or not. And so for that, I did the cross section using Google Earth and some other tools as well. So these are the some of the area. So I take the cross section for each 1 kilometer successively, so that I'll define the where the setting is confined or unconfined, and also identify the geomorphic unit like floodplain, the terraces. And for that, I have validated those places, as you can see here, which shows like the whatever the cross section I have done, I have just validated that those regions are there or not. And apart from this, I also did the like quantify the flood where the active floodplain is. For that, I have using SAR data, which is 12, which is from 2015 2024 2024. So identify the active floodplain in the region. And apart from this, I also measure the grain size. So for the larger grain size, I have used the AI-based segmentation method. And for the smaller size, I have taken the sample from the field and analyze in the laboratory. And I also measured the velocity of the river using a current meter instrument along the river. And apart from this, I have also made the geomorphic map using Google Earth and the other software tools. And I also find the like whatever the geomorphic unit is which is present along the river. And also I have validated those geomorphic the unit in the field. As you can see, in a different month I went to the field, and I'll see like those places are actually it is there or not. So like here you can see in the May, this is the floodplain which I have proposed when I went to the September, which is the monsoon time in India. So this shows like that this area is inundated by water, which shows that this plain is this area is a floodplain. As you can see, there is a green color in this map. And if I go to my results, I also calculate the slope of the river from the upstream to downstream, which is around 1300 kilometer, which shows the variability along the river. And using this, I have also did the hydrological analysis using the Gumbel method for flood frequency flood frequency analysis. And using this flood frequency analysis, I have make the relationship between the discharge, and these data is from the gauging station, which I have earlier showed you, the gauging station along this Narmada basin. So these are I have made the relationship between area and discharge, so that I got the discharge for the each and every point along the river. So for the using this discharge and area relationship, I have calculated the stream power. So stream power helps to understand the energy condition along the river. So these are the energy condition along the river, as you can see, from the upstream to downstream. So earlier, if you from upstream, the stream power is not that much, but as it is going downwards, the stream power is increases. And you can see the stream power formula. And I have used the power law to quantify the stream power all along the river. And
Could you
apart
please
from,
move to your conclusions for us?
yeah,
All right. Thank
okay. So these are the 18 river styles which I have made, and these are the some of the details of the river styles. Uh, and if I talk about the controlling parameters, so I have put it all the major parameter which I have done in the field, as well as by using some secondary data. And using this, I have also compared all the river style with the different parameters and the all the structural variability or the tributary variability along the river. So based on this, the conclusion of this my result is that I have identified 18 river style along the river. Out of this, 64% is confined, 31% is partly confined, and 5% is unconfined. And the 57 kilometers reach along the river, which is near the Barwani, which is the city near the Narmada river, which shows the unconfined nature because of the anthropogenic causes, because of the Sardar Sarovar Dam construction. And these unconfined valley settings are more sensitive to any for the ecosystem, which is going to be disturb the ecosystem nearby, nearby like the human settlements as well. And these are the controlling like parameter which is influencing the different river style. These are the valley slope, stream power, the lithology, and the tidal influence, and the anthropogenic disturbance, which is like, as I have already discussed, like that this river is highly regulated river. And these are the references. And thank you.
All right. Thank you, Sunny. Um, we can take one or two questions just for Sunny and for Ismaila. If you have any, you can type it in the chat and I'll read it to them. Sunny, I was just curious. What is the underlying geology of the river you showed us?
Underlying geology. So I have showed you like the geology is mostly Deccan Trap is there. Hello, am I audible? Hello.
We can't see you.
Okay, sorry.
Yeah. Could you take
So
it? Could you answer
uh,
again? I didn't get that.
so the geology part. So the river is mostly flowing through the Deccan Trap. So that is a basaltic in nature. and uh, and there is number of fault is there also, like the Narmada fault, which is not an active fault right now, but yeah, in geological past it is active, and you will find number of waterfall because of this faulting activity.
Okay. We have a question from Shraddha, and I think that will be our last question for today. She said, nice presentation. Just wondering how the anthropogeny has led to a change in the river style.
Actually, the thing is like near the Sardar Sarovar Dam, like this is the one of the major dam in India. So because of that, there is a the backflow of water. So the water level is get rises in that particular reach, which is near, which is upstream of the Sardar Sarovar, which every year during a monsoon period, the reservoir capacity is reached, and because of that, the lateral expansion of water is happen, and because of that, the inundation happen both along the river bank. And so that's why like the anthropogenic is the real causes for the lateral unconfined valley setting that particular region. So if there is no dam, so there will be a no any floodplain there, because I have seen the last 10-year data where when there was no any dam. So that's so that the area is confined, but because of the dam construction, so the river inundate those like the bank near the upstream of that the reservoir.
Okay. Uh, Thank you very much. I think that's all for the questions for today. And we would like to thank everyone who made time to join us for the webinar today. Just to remind everyone, that webinar will be recorded, and it was recorded, and it will be posted on the YouTube channel, and the links for that will be made available once all the post-processing has been completed. So once again, thank you for joining us, and we hope you have a nice rest of your day.